Hi, everybody. Today we are going to solve one very interesting problem in physics. That is uh, this problem where three of the friends, so three people are standing at the vertices of the equilateral triangle. Let's assume this as an equilateral triangle ABC. They are standing at each of the vertices of the triangle, and they chase each other, move towards each other, and they continue this pursuit until they meet at some point, and we'll see that point is the centroid uh, of this equilateral triangle, and they are moving with a constant magnitude of velocity v towards each other. The direction, of course, will keep on changing because as a progresses further, b will be progressing towards c. So there will be a movement of b. So a has to change its direction accordingly to point towards b. In the same way, b will change its direction towards c, and c will change its direction towards a. So it looks like apparently a difficult problem to solve. So we'll try to solve this. So we'll determine the time to meet together. And I have drawn this to illustrate this path better, or how this will look like with time. So P, Q, R are essentially the vertices of the triangle, and we have person A, person B, and C in green font. So they are moving towards each other with V, and we have assumed the side of the triangle as A, which is also given. It's not the assumption. So we have the side length given for this triangle as A, and our objective is to find the time it will take to meet in the center of the triangle. And we can see the triangle is kind of rotating, right? Initially, they're making the triangle. After some time, there will be also triangle, but uh, it will be little tilted, and in the same way that will continue, and triangle will keep on moving in anti-clockwise direction, and eventually it will meet at the center point. So let's try to understand this better. So A is moving towards B. So let's assume for very small time, delta t, which is tending to 0, A has moved a little bit, which is also tending to 0. So we can safely assume it to be a straight line, and is tending to 0. In the same way, B will also move a little bit, right? So that is true. So A will shift its position, and it will continue to do that, and it will start making some angle, say theta. So A will make angle, for example, theta, with the initial line that is connecting A and B. So it will continue to happen, and until they meet at some point, which is at the center of the triangle, right? So B will also have a kind of a curve trajectory, and C will also have some curve trajectory, and they will meet at point. Say the point is C, not C. C has been used. We can use it as a for the center, right? So this will happen at every point in time. If we take the snapshot of the position of the friends, it will always make an equilateral triangle as well. All right. So let's try to solve. So at a specific time. So yeah. So let's generalize the distance between A and B. So let me select the right color. So at some time, A and B, at some time, let's assume A is at this position and B is at this position, and they have a distance of S, right? So S is shrinking. I'm giving you T equal to 0, S is equal to A, and T equal to T, S is equal to 0. And this T is the time taken by all of them to reach and to meet together, to reach to the center of the triangle. Time taken by these people to reach center of triangle where they all meet. Let's solve this further. To solve it easily, what we will do, we will draw the axis. So this is x-axis. Let's assume this is y-axis, and this is the position of person A, and this is the position of person B on the x-axis, right? And we can safely assume the coordinates of B as S, which is on x-axis, and 0. So what we have done, we have drawn our axis along this path, which we can freely do. So this is S comma 0. S is the x-axis because this is S and it's on the x-axis, so y would be 0. The displacement of B with respect to A is position vector of B minus position vector of A. What is position vector of B? It's SI. There is no y component. And what is RA? Is 0. So we have RBA, which is position of B with respect to A, or the displacement of B with respect to A. If we differentiate it, RBA, which is equivalent to VBA, velocity of B with respect to A, is this ds by dt I, which is in this direction. So this is equation 1. We can also write VBA as velocity of B minus velocity of A. Let's calculate the velocity of B. So we know that B is moving towards C. So, and we drew the coordinate system in line connecting the line A and B, and B is moving in this direction. So at this point where B is located, instantaneously, okay, at that point, we are going to have velocity V making an angle of 60 degree. And hence, let me get some different color. Hence, the velocity contribution in x direction would be v cos 60 in negative direction towards the origin, which is opposite of I. So we can write minus v cos 60 degree minus what is A. So A is moving towards B with velocity v at this point, and it will change its direction. But for this instant, this is true. So it's v. So it becomes v by 2 minus v, which is equal to 3v by 2 minus 3v by 2. VBA. And we need to put I, sorry. Directions are important. I vector. So this is from 1 and 2. What do we get? ds by dt. And since both of them are having I vector, so removing the I part, and we are just focusing on the magnitude, right? Now we can integrate this ds. We can write this as 3d by 2 dt. Can we integrate this? Right. So integrating would be what? So the initial position is what? It's A, because the initial separation. Okay. So the initial separation is A, and we mentioned that part over here, somewhere here, right? So initial position is A. So we are changing from initial position to final position, which is at time t over here, s equal to 0. So s is equal to 0, and this time is from t equal to 0 to t. So this becomes minus a, and this becomes 3b by 2 t minus. Hence, we get the time as 2a by 3b. So this is the time. Okay, so this time would be the time taken by these people standing at the vertices and moving towards each other to meet together, right? So we have solved this problem. So we got the time t, and we can also find out the total distance covered by these people. So total distance covered by each person, that would be t into v. Why? Because velocity is constant, means the magnitude of velocity is constant. So from this equation, let it be 3. So we can write 2a by 3b multiplied by v. So 2a by 3 would be total distance covered by each person. Okay. So let's look at the problem again. What did we do? So we understood how they are moving, and they will be moving towards each other, eventually be meeting at the center of the triangle, equilateral triangle, and they will always make the equilateral triangle because of symmetry, of course. And we can solve this as well, and their magnitude of velocity is constant. So what we did, we have chosen one of the triangle, and we said that let it be s, the separation in between a and b to be s, which will constantly reduce with time. But at time equal to 0, the separation is a, and time equal to t, the separation is uh, right. So at t equal to 0, the separation in between them is a, which gradually reduces. And at t equal to t, when they meet together, the s becomes 0. So what we did, uh, we created a coordinate system where the x-axis is aligned with the line joining A and B. So and placing the person A at the origin. So here you can see. So we have drawn the same. Now the person is at origin. The person B is at position where the coordinate is s, because the separation is s. So x-axis is s and y-axis is equal to 0. The displacement or the difference in the position vectors is for, okay, so the separation vector, okay, so position of b with respect to a is rb minus ra, it's si, and then we got the the position vector of b with respect to a is si, and then we differentiated it. So we got the velocity of b with respect to a, ds by dti. Velocity can also be written in this way, Vv minus Va, and what is Vb, which is the velocity V, the magnitude is V, but it has a component of V cos theta in the x direction, but in the negative x direction. So we have put it in the vector form, V cos 60I minus V. A is V, it is across it is towards the x direction. So it's 3b by I, and then from this equation 1 and 2, we got this. We differentiate, we integrated this, so it became uh, t. So we got t equal to 2a by 3b, and the total distance covered by each person would be the time it took to meet. multiply by the constant magnitude of velocity. So it's 2a by 3. So here the important thing is the concept that we must understand, and having the conceptual clarity will make you solve any questions. Thank you.